Hey everyone, welcome. So today we're going to talk about something really cool, a brand new AI architecture that's making waves. It's called the Dragon Hatchling, or BDH for short. And the reason it's so exciting is that it might just be the missing link we've been looking for between the AI in our computers and the, OG intelligence inside our own heads. Let's get into it.
Okay, so let's just start here. AI is getting smarter at a frankly terrifying pace. It can write poetry, it can code, it can make art. But here's the billion-dollar question. Do we actually have any idea how it's thinking? For the most part, the answer is no. These massive models are what we call black boxes. And that's a huge problem, right? How can you really trust a system when you can't follow its logic? And this really gets at the heart of what some researchers are calling AI's Great Divide. It's this massive chasm between how our best AIs work and how the most efficient, most incredible computer we know of, the human brain, works. So on one side of that divide, you've got today's big AI models, the transformers. I mean, they're absolute powerhouses, no question. But they're also kind of clunky, inefficient, and their inner workings are a complete mystery, a tangled mess. But then you look at the human brain. It's the original intelligence. It's super efficient, it's sparse, meaning only a tiny fraction of your neurons are active at any one time, and it operates on principles that, bit by bit, we're actually starting to understand. So the big question is, how do you build a bridge across that divide? Well, that's where the Dragon Hatchling comes in. It's this really elegant new idea that's built on two beautifully simple principles, one from the world of logic and one straight out of neuroscience. So, the first building block is a rule of logic that you, me, all of us use constantly without even realizing it. It's called modus ponens. It sounds fancy, but it's dead simple. It's just, if it's raining, and you know that rain makes the ground wet, then the ground is wet, right? It's the absolute bedrock of how we reason about the world. And the second piece of the puzzle comes directly from how our brains actually learn. It's a concept called Hebbian learning, and you've probably heard the famous summary: neurons that fire together, wire together. It just means that every time two brain cells are active at the same time, the connection between them gets a little bit stronger. That's it. That's how our brain learns to associate things. And this is the real aha moment. The beauty of the Dragon Hatchling is that it takes that rock-solid logic of modus ponens and fuses it with the brain's own learning mechanism. So you end up with an AI that doesn't just mimic intelligence. It's actually built using the fundamental rules of reasoning and learning. All right, so we've got our two main ingredients, a logic rule and a brain rule. But how does that actually become a working AI? How do you put those pieces together? Let's look under the hood. So instead of the really complex data structures you see in today's AIs, BDH is designed as a network of what they call neuron particles that just interact with their neighbors. You can kind of picture it like a bunch of little oscillators that pulse and influence each other. And they've created two versions of this. There's the pure BDH, which is the really brain-like theoretical model, and then there's BDH GPU, a version that's been streamlined to run super efficiently on the hardware we all have today. Okay, this all sounds really cool in theory, but here's the real test. Does it actually work? And more importantly, does it actually solve that black box problem we started with? Let's check out the results, because this is where it gets really good. So first off, the performance. Get this, when you compare a BDH GPU model to a standard transformer of the same size, like GPT-2, it performs just as well. That is a massive deal. It means we don't have to trade power for understanding. We can have an AI that's both incredibly capable and something we can actually interpret. But here it is, the real game changer. The researchers say that for the Dragon Hatchling, interpretability isn't some add-on you try to tack on at the end. It is an inherent feature of its design. It was built from day one to be understood. So what makes it so transparent? Well, it comes down to three things. First, its activity is sparse, just like our brains. Only a few neurons light up for any given task. Second, the signals are simple. They're basically just on or off. And third, and this is just incredible, the neurons are what's called monosemantic. That's a fancy word, but it means you can literally point to one single neuron particle in the system and say, that one means cat, or democracy, or love. One neuron, one concept. The AI's thoughts are suddenly traceable. So when you have that level of clarity, it completely changes how we think about AI safety and trust. We can move beyond just trying to interpret AI and start building what this research calls axiomatic AI. Okay, so what's the difference? Well, the old way, interpretable AI, is where we build a black box and then spend all our time trying to poke and prod it to figure out what it's doing. But with axiomatic AI, we start with simple, understandable rules, the axioms. And because we understand the fundamental building blocks, the entire system's behavior becomes predictable from the get-go. This is a total paradigm shift. We go from trying to guess what an AI might do to designing its behavior to be trustworthy from the ground up. And this table just brings it all home. Look, on the far left, you have the messy, opaque world of the transformer. On the far right, you have the elegant, understandable world of brain models. And smack dab in the middle, you see BDH and BDH GPU. They are the bridge, translating the dense, confusing mechanics of today's AI into the sparse, simple, and understandable dynamics of a biological brain. So let's be clear about the takeaway here, because it's huge. The Dragon Hatchling isn't just another clever model. It could be a pathway to discovering something much, much bigger. The actual, literal equations of reasoning that govern how all intelligent systems think, whether they're made of silicon or cells. And that just leaves us with one final, kind of mind-blowing question. If we're building an AI based on the fundamental rules of logic in the brain, are we getting close to finally reverse engineering the language of thought itself?